Assalamu alaikum and hello everyone. This is Mehraj Kamran and you are watching Explore Chemistry. Today we are going to study about isotopes and uses of isotopes. So let's start. Before studying isotope, I want you to teach something about atomic structure. For detailed description video, you can watch my previous video related to structure of atom. As you all know, atom consists of nucleus inside in the center of the atom. In this nucleus, there are two subatomic particles present, neutron which carry zero charge and protons which carry positive charge. Outside this nucleus, electrons revolve in shells or orbits. Electrons carry negative charge. So, atomic number, which is represented by Z, it is the number which tells you proton number or number of protons present in any atom. And mass number, which is represented by A, it is the number which tells you sum of proton and neutron. Therefore, it is also called as nucleon number and mass number. It tells you the subatomic particles present within the nucleus. Now, isotopes. What are isotopes? Isotopes are the atoms of the same element which contains the same number of protons but different number of neutrons. This is important. These are species related to the same element having same number of protons but different number of neutrons. Means same protons, positive charges with different neutrons, and they belong to same species, same element, same type of atoms. Because their number of neutrons are different, so they can have same atomic number which is represented by P or number of proton but different mass number. Because neutron will change, so their mass number will also change. So isotopes can also be defined as the species or atoms of the same elements with same atomic number but different mass number. Therefore, isotopes are having same electronic configuration and chemical properties because electronic configuration belongs to number of electrons present in shells or subshells, and chemical properties are also related to electrons. By donating or transferring or sharing electrons, any atom can perform any chemical reaction. So chemical properties as well as electronic configuration of isotopes remain same, but the physical properties may differ because physical properties belongs to mass of any atom. By increasing number of neutrons, mass will also increase. Now we will discuss some examples. In this way, you can understand more clearly that what are isotopes. Let's discuss the isotopes of hydrogen. The first isotope or ordinary hydrogen, its name is protium. It is called as ordinary hydrogen because it is the hydrogen which we know. Its atomic number is 1, mass number is also 1. In the nucleus there is 1 proton, no neutron present and 1 electron. So subatomic particles are like this: electrons 1, protons 1, neutrons 0. Therefore atomic number 1 and mass number is also 1. There is another isotope of hydrogen which exists in nature. Although it exists in less percentage as compared to this ordinary hydrogen, but it exists in nature, and these are naturally occurring. It is known as a heavy hydrogen or deuterium. In the atomic structure of deuterium, there is 1 proton present and 1 neutron is also present. This is very rare hydrogen, but it exists in nature. If you will see subatomic particles of this species, it is having 1 electron, 1 proton, but neutrons is also 1. So atomic number will remain same, that is 1 as compared to this isotope, but mass number will be 2. By adding 1 proton, 1 neutron, we will get 2. So now these two are isotopes of hydrogen because they belong to same element, but they are having different number of neutrons. One is having 0 neutron, another is having 1 neutron, and different number of different mass number also. But electrons, protons are same, atomic number is same, therefore their chemical properties are same, Their electronic configuration is same. One electron in first shell, here also one electron in first shell. But their physical properties are different because the mass of this hydrogen is more than the mass of this hydrogen. There is third one, another isotope of hydrogen which is known as radioactive hydrogen because it shows radioactive nature. The name of this isotope of hydrogen is tritium. This isotope contains 1 proton, 1 and 2 neutrons. It contains 1 proton and now 2 neutrons. So its nucleus will become heavy as compared to these two. The subatomic particles of this isotope, electrons 1, protons 1, neutrons 2. Therefore atomic number 1, but now mass number is 3. So these three are isotopes of hydrogen. So these are the species of the same element having same number of protons but different number of neutrons. Now you understood what are isotopes, and these are naturally occurring. Now we will discuss isotopes of carbon. The first isotope of carbon is known as carbon-12, which is ordinary carbon. This contains 6 protons and 6 neutrons. Its subatomic particles are 6 electrons, 6 protons, 6 neutrons, atomic number 6, mass number 12. This is the carbon which you know about. This is the most common carbon. Another isotope of carbon is carbon-13. Mass number is 13 now. It is having 7 neutrons. Proton numbers are same but neutron numbers are different, you can see. Subatomic particles, electrons same, 6, protons same, 6, neutrons different, that is 7. Therefore atomic number is same, 6, but mass number is 13. The third isotope of carbon is known as carbon-14. This is also radioactive carbon. It contains 8 neutrons. So its subatomic particles are 6 electrons same, 6 protons same, but 8 neutrons are present over here. Atomic number is same, 6, but mass number is 14. So these three are isotopes of carbon. Now we will discuss isotopes of oxygen. First isotope is oxygen 16, which is common isotope of oxygen. It contains 8 protons, 8 neutrons and 8 electrons. Subatomic particles are like this: 8 electrons, 8 protons, 8 neutrons, atomic number 8 and mass number 16. Second isotope of oxygen is known as oxygen 17. It contains 8 protons and 9 neutrons. Electrons are same 8, protons are same 8, but neutrons are different, having 9 numbers of neutrons. Atomic number is same, mass number is different, 17. Third isotope of oxygen is known as oxygen 18. This contains 8 protons but 10 neutrons. Subatomic particles are like this: 8, 8, 10, and atomic number 8, mass number is 18. Now if someone asks you what is the mass number, atomic mass of oxygen, then you can't say that atomic mass of oxygen is 16. Then these two oxygens also exist in nature. So for calculating atomic masses of any element, we need to calculate average atomic mass of all the isotopes, including their percent abundance. In periodic table, you must have seen atomic number with each element written in points. So this atomic mass is written in points. So this atomic mass is actually the average atomic mass of all the isotopes. You must have seen oxygen atomic mass is written 15.999. So it is actually average atomic mass of all three isotopes, including their percent abundance, because the percentage of this oxygen isotope is highest in nature as compared to these oxygen isotopes. Alright, now we will discuss isotopes of chlorine. Chlorine is having only 2 isotopes. Only 2 isotopes of chlorine exist in nature. First one is chlorine 35, which is common isotope. It contains 17 protons and 18 neutrons. Subatomic particles are like this: electrons 17, protons 17, neutrons 18, atomic number 17, and mass number is 35. As you all know, you used to write atomic mass of chlorine as 35.45 or 35.5. That atomic mass is actually average atomic mass of both the isotopes. Second isotope of chlorine is chlorine 37. It contains 17 protons and 20 neutrons. Subatomic particles are like this: 17 same, electrons 17 same, protons but neutrons are different 20. Atomic number same 17 and atomic mass is also different 37. So average atomic mass of a chlorine element is 35.45. With respect to the percentage abundance of both the chlorine isotopes, because this chlorine isotope exists in 75% in nature and this chlorine isotope exists as 25% in nature. Alright, now we will discuss one radioactive element, uranium. All three isotopes of uranium are radioactive in nature. There are three isotopes. First one is uranium-235. Its subatomic particles are like this: electrons 92, protons 92, neutrons 142. Atomic number 92 and mass number is 234. Another isotope of uranium is uranium-235, which contains 92 electrons, 92 protons, which are same, but 143 neutrons, which are different. Atomic number is also same, 92, and mass number is also different, 235. The third isotope of uranium is uranium-238, which contains 92 electrons, 92 protons, but 146 neutrons. 92 atomic number, but mass number is 238. The atomic structure of uranium is very large because it contains 92 electrons. So here you can see its nucleus is very heavy. So uranium is a radioactive element. Those elements which can emit radiations, they are considered as radioactive elements. Now we will discuss applications or uses of isotopes. Isotopes are very useful in various fields. First, we will discuss the uses of isotopes in radiotherapy, which is also known as treatment of cancer. Radioactive isotopes are used in this procedure. It is a procedure which is used to treat cancerous cells with minimal damage to the normal surrounding tissues. The isotopes which are common for this use are like phosphorus 32, strontium 90. They are used to treat skin cancer because they emit less penetrating beta rays which cannot go inside the body. Cobalt 60 is used for cancer within the body because it can emit strongly penetrating gamma rays which can penetrate within the body. Next use is isotopes can be used as tracers for diagnosis of diseases and medicines. Radioisotopes are widely used to diagnose disease and as effective treatment tools. For diagnosis, the isotope is administered and then located in the body using a scanner or some other sort. The isotopes which are used for this purpose is technetium 99 M, which are used as tracer to diagnose the presence of tumor in body because it is injected in the body and the movement of this isotope is traced by using any scanner. Another radioactive isotope is iodine 131, which is used to diagnose goiter in thyroid gland. Next use of isotope, it can be used in archaeology and geology. This is very important use. Isotopes are used to find the ages of rocks, meteorites and archaeological objects. They are also used as tracers to understand geological and environmental processes They help determine the age of the Earth and explain the formation of chemical elements. By using isotopes, scientists have determined the exact age of the Earth or age of any fossil. Is this interesting? For example, there is a process which is known as carbon dating or radiocarbon dating. It is a method for determining the age of an object containing organic material or mainly carbon-14 element by using the properties of radiocarbon. An age could be estimated by measuring the amount of carbon-14 present in the sample and comparing this against an internationally used reference standard. As I have told you that carbon-14 is radioactive isotope. So if it is found in fossil of any species, once it will be found, any scientist can find that what is the life of that carbon-14 at the time of formation, how many radiations have been emitted from this carbon-14 and how many is left. So one can identify half-life of this radioactive element. Through that half-life, scientists can identify the age of that species in which this carbon-14 element is present. By using this method, scientists have identified the age of dinosaurs. So this is very interesting. Next use of isotope is to determine structures and to determine the path of any reaction. Isotopic labeling is a technique used to trace the passage of an isotope through a reaction, metabolic pathway or cell. With information about the position of isotopic atoms in products, the reaction pathway can also be determined with the structure of product. For example, this carbon dioxide contains isotope of carbon. So from where till where this carbon will go, in this way we can find the path of this reaction and the structure of the product which will form. Another very important use of isotope is in power generation. Radioactive isotopes are used to generate electricity by carrying out controlled nuclear fission reaction in nuclear reactor. This is an example of nuclear fission reaction in which a uranium-235 atom is absorbed, or this neutron is absorbed in this uranium-235, or in other words you can say this uranium-235 is bombarded with this nucleus. As a result, this nucleus will become heavy, more heavy. Its atomic mass will become 236 and it will split into two nucleus. These two nucleus will form new nuclei with different atomic mass. One with 92 mass number, another with 141 mass number. 92 mass number is the mass number of krypton and 141 is the mass number of barium. So through this fission reaction, new elements can be formed. From uranium, we have prepared krypton and barium by using this simple fission reaction. This will not over here. This reaction will produce 3 neutrons as well as large amount of energy. This energy is very useful, which is produced during any nuclear reaction. These are the types of nuclear reaction where reaction is taking place within the nucleus. Nucleus is splitting into two new nucleus. So these type of reactions are known as nuclear reactions because these reactions produce large amount of energy. Therefore, it is performed in a nuclear reactor. It cannot be performed in open environment. Now, the amount of energy which is released, this energy can be used to convert water into steam in boiler. Here you can see this is reactor vessel. The energy which is released is passed in this steam generator, which is a boiler. Over here water is converted into steam and then this steam moves towards turbine. It moves the turbine, and due to the movement, mechanical energy is produced. Then there is a generator over here. Here, this generator converts mechanical energy into electrical energy. In this way, electricity can be produced. So here you can understand this whole process. Here a fission reaction takes place. Energy is used to convert water into steam. That steam will move the turbines which produce mechanical energy, and generator will convert mechanical energy into electrical energy. So in this way, by using simple isotopes and nuclear reactions, we can produce electricity. This is all about isotopes, and these were all uses of isotopes. Hope you understood each and every point. If you did not understand anything, you can ask in comment. If you understood everything, please like this video, share with your friends, and subscribe my channel for more important videos. Thank you.